Hello and welcome to this module on running code in Azure or looking at compute in our cloud environment. I'm here to help you dive into the various compute options in Azure. We'll start by talking a little bit about computing in the cloud. What does that actually mean when we talk about compute services? Then we'll review some of the solutions in Azure and give you a little comparison between them. Finally, we'll talk about some examples to help you plan what might be the appropriate compute option for you as you investigate building your solution or migrating your solution in Azure. When we talk about compute in Azure or in the cloud, we're really talking about the CPU and the memory that you're going to use to run your application code. Whether that comes in the form of a virtual machine where you're specifying a CPU and memory, or you're choosing a particular scale size for a service, such as an app service that might host your web application. But it's all about running your application code. In Azure, there's a variety of different options, and at a high level, there's a few buckets. You can start with virtual machines, which are very familiar to many people, something they've used in their own data centers. You can create these with a variety of parameters, and then install your applications on them and execute them. Azure App Services allow you to run web apps or web APIs in a hosted environment or that platform as a service model. There's support for containers, a popular application packaging format, and a set of tools for running those applications. And there's also serverless compute, the idea of running application code without thinking about instances, virtual machines, or any of that underlying infrastructure. When you think about virtual machines in Azure, of course, we have some things that will be familiar. You can create a Linux virtual machine or Windows virtual machine, and you provision those out in Azure and are going to specify things such as how many drives do you need? Should those be solid state drives or not? What kind of speed do you need or IOPS do you need from that particular VM for performance? And you can choose the size or scale of that, which comes down to how many cores in CPU, how much memory do you need? Additionally, though, there are a number of virtual machine images available in Azure so that you're not provisioning a bare bones Windows or Linux VM. You can provision one that's already set up and may already have applications installed that you're going to use. Because we're in the cloud, and one of the things we want to take advantage of is that scale and that flexibility, there's another set of features, such as scale sets, that you can take advantage of. And these are going to allow you to identify a VM image, and then as your load increases on your virtual machines, Azure can automatically scale the number of virtual machine instances based on that image for you. And that goes both ways, up and down, so that if you're not busy, you're not paying for virtual machines that you're not using. Likewise, in the cloud, we could take advantage of availability sets. Because we have all these resources available to us, we can identify different virtual machines, put them into these availability sets, and Azure then will help manage making sure that your system is highly available. Now, I mentioned provisioning your virtual machine and disks. Because these are virtual disks that are in storage, one of the great features that Microsoft has provided is the notion of managed disks, where Microsoft manages the storage and the back-end handling of those disks for you and keeps them all connected and working with your virtual machines. Along with all this, of course, there are backup services and networking services that you can use to manage and connect all these virtual machines. So a lot of familiar things with virtual machines, but also some very specific cloud features that you can take advantage of. Azure App Service is all about providing you a platform to run your web applications. Whatever that language is, you're running PHP, Node.js, Java, or ASP.NET, for example, you can deploy those web applications in the Azure App Service. You've got flexible deployment options. You can integrate with Git-based repositories. You can use Azure DevOps in order to deploy. You can even do local deployments or FTP if you need to. App services are built with scaling in mind so that you can identify your web application code and the scale characteristics, and Azure will automatically take care of scaling the application up and down for you so you've got the right number of instances to handle your traffic. It's also a notion of application healing. This is one of the benefits of a platform as a service. When you're not managing that underlying infrastructure, if one of your nodes goes down, Azure can take your application code, deploy it on a new node, and bring that up in its place so that you don't suffer downtime and your nodes get healed automatically. There are a lot of other features around the app service. One of those is the notion of deployment slots that really helps you in moving from, say, a staging environment to a production environment with a very simple ability to deploy, warm up your staged code, test it out, and then swap it into production. Like virtual machines, we have all sorts of capabilities around this service with networking and storage in order to augment the running of your application code. Containers have fast become a very popular mechanism for packaging and deploying applications, and Azure has full support for Kubernetes, the most commonly used orchestrator for containers. The Azure Kubernetes Service makes it very easy for you to provision a Kubernetes cluster and scale it and set it up the way that you need. Azure also provides a notion of container instances. And this is the idea that you have a container defined and you want to run an instance of that container. You don't want to have to provision a whole cluster or infrastructure to do that. You simply want to take that instance and run it for some period of time. That may be a standalone instance that's short running, or you can use this in conjunction with the Azure Kubernetes Service to do what's called virtual nodes, where you can add in from the container instances nodes to help scale your Kubernetes service. And of course, with all these containers and container definitions around, we have the Azure Container Registry. This is where you can take your container definitions, catalog them in the registry, making them available for your container instances or your Kubernetes service to be able to pull those containers and execute them or host them in those environments. So there's a very rich ecosystem within Azure with support for all the latest standards, the standard tools and frameworks for managing and executing those containers. Serverless computing is the notion of having code and applications execute without having to manage instances of virtual machines or even think about instances of, say, a web application. Azure Functions is one offering in this serverless space that allows you to write code in the form of a function using a variety of different languages, everything from C# to JavaScript and even PowerShell, that allows you to have those run on demand, usually triggered by some sort of external stimulus. Maybe an HTTP request, maybe some other sort of event or a message arriving. There's also logic apps, which similarly run without the notion of a particular server instance and provide workflow and orchestration of different integrations between systems. We'll talk a bit more about that when we talk about integration. And the event grid, which allows you to have a very robust mechanism for a publish and subscribe model for different events that may be happening in your applications or even in your infrastructure, allowing you to respond to things like virtual machines starting or stopping, or to application events that happen. All of these run without you managing particular instances, and logic apps and Azure Functions are all about allowing you to write code without concern for that platform infrastructure setup. The serverless model can really greatly simplify the work that you do in managing the underlying platform. Not everything's going to fit into those buckets neatly. For example, I mentioned those Azure container instances, and they can be used as a virtual node for the Azure Kubernetes service. They can fit into the serverless model as well, where a particular event happens or some sort of trigger occurs, and you have a container instance that gets created, runs for a short amount of time, and then gets torn down. Gives you the benefit of not worrying about the infrastructure and managing those things using the container technology. Similarly, Azure Service Fabric is an offering that's available that allows you to tie together a number of different services in a managed infrastructure. Those services might be containers. They could simply be an executable that you've created, or web applications or web APIs. Service Fabric doesn't really care about the different pieces and allows you to mix and match not only containers, executables, and web apps, but you can mix Linux and Windows containers and images as well. So while we have some very set and familiar solutions like a web app or a virtual machine, we also have these cloud optimized solutions with serverless and the use of containers and Service Fabric for managing those things. Talking about compute in the cloud wouldn't be complete without at least a mention of compute at great scale. And here I'm talking about the Azure Batch service, which allows you to manage scheduling out of jobs at scale. And this is where you might need hundreds or even thousands of instances of a virtual machine or an executable to be able to go and run in parallel to process a large amount of work. Azure Batch allows you to set that up and manage it for those big burst workloads that you have. Likewise, I'll mention HD Insight. This is a set of tools within Azure that's built all around the open source frameworks for Hadoop with all sorts of processing capabilities around big data and compute that you can take advantage of. So if the other things I've talked about in terms of virtual machines and containers don't sound like they're going to fit because you have a massive scale in what you need to do or parallel processing, then you may take a look at Batch and HD Insight, see if those are a better fit. I'll walk through a couple of examples here just to give you some ideas of how you might use this compute in Azure. And one might be a simple VM migration. If you're running Windows or Linux virtual machines today, maybe in Hyper-V or VMware, and you want to now run those virtual machines in Azure, you can do some analysis. There's some tools that can help you out with this to figure out whether this is a cost-effective move for you. Maybe it's not about cost, it's about taking advantage of all the scale and the other features that we talked about with scale sets, availability sets, and managed disks. Regardless, you can make this move, and there's actually an Azure migration tool that you can use that will analyze your existing virtual machines up to tens of thousands. So even if you've got a huge data center here, and give you a path and tooling to migrate those things into Azure. In addition to just migrating virtual machines, the tool understands web applications and databases and a lot of third-party vendors' applications as well. So if you're looking at migrating virtual machines and applications into Azure, take a look at that migration project. Another example to give you a sense is that you may want to build out a Kubernetes cluster. For example, if you've got 3 web application nodes, you've got a couple of API nodes, maybe a single cache server node, and you want to use all of the Kubernetes tools to manage and deploy this in a cluster using container technology, you can do that. You can use all of the command line tools from Kubernetes. You can do local development with your Docker client if you want, and build up your YAML file that defines that deployment and deploy or bring up an entire Kubernetes cluster and manage it out in Azure using that Azure Kubernetes service. And finally, an example for a web application. And maybe you want to have a scalable global web application that's available in a variety of regions. So you could have a region 1, maybe in North America, that has 2 instances of your web application and a Cosmos DB database. That Cosmos DB database has the ability to do geo-replication behind the scenes to ensure consistent data in a very fast and transparent model, so that that data can be migrated or transferred or synced between multiple regions. So in region 2, maybe that's Europe or Australia or India, you've got another instance of your web applications and that Cosmos DB database in that geo-redundant setup. So this is just a few examples of some of the different things you can do with the compute options in Azure, keeping in mind that there's a lot of supporting services that you might use, such as networking or the database services and storage services behind the scenes. So we've looked at a variety of different compute options in Azure. Hopefully that gives you a sense of some of the things that you can use, all the way from familiar options like web applications and virtual machines to more modern things that may not be as familiar to you, such as containers, the service fabric, and the serverless options. all of these different options are built for the cloud. They're all built to be able to scale and meet demand. And they have different ways that you can configure that, but they all give you the capability to stand up your application and identify the different scale characteristics and manage to those. The Microsoft Azure Cloud isn't just about Microsoft technologies. You're going to be able to use VMware virtual machines if you need to. You're going to be able to use JavaScript and Java applications or PHP. So regardless of what type of application you're building, you're going to have support in the Azure Cloud to deploy that application and manage it in a variety of different compute options.